Okay, this is problem number 8 from worksheet 1.1. So this is a two-part problem where the train begins a uniform acceleration from rest and has a speed of 23 meters per second when it passes a railway worker who's standing 220 meters from where the front of the train car started. What will the speed of the last train car be as it passes the worker? So we want to figure out the two parts here. Part 1. Part 1 is where the train is approaching the worker. So our delta x for that part is going to be 220. The initial velocity is going to be 0, and the final velocity is going to be 23 meters per second. In part 2, we have our delta x. This time is the 97 meters because that's going to be the length of the train car that passes the worker. The initial velocity of that is going to be the final velocity from the first part, so 23 meters per second. And we're looking for the final velocity for that part. We don't have enough information to solve for anything in part 2 yet, but if we find the acceleration is constant for both parts, since it's uniform acceleration, so if we find the acceleration for part 1, we can use that acceleration to solve for the final velocity in part 2. So we're going to find a here, and then use that a in part 2 to figure out the final velocity in part 2. So the equation we want to use is Vf squared equals Vo squared plus 2a delta x. So now our final velocity is 23 squared equals 0 squared plus 2, and whatever a is, times, that should be a 0 over there that I missed, times 220 meters. So now we get 23 squared is 529 equals 2a times 220 meters. So divide both sides by 2 and divide both sides by 220. We get 1.20 equals a. That's 1.20 meters per second squared. So that's our a for over here. 1.20 meters per second squared. So a for over here now as well. So now I've got an x here as well. Delta x, Vo, and a. And we're going to find Vf, so we're actually going to use the same equation again. Vf squared equals Vo squared plus 2a delta x. Vf squared equals 23 squared plus 2 times 1.20 times 97 meters. And when we solve that, we get Vf squared equals 3 squared plus 2 times 1.2 times 97. Vf squared equals 761.8. That's a terrible 8. And then we take the square root of that. And our final velocity as the last car passes the worker is Vf is equal to 27.6 meters per second. That's an awesome M as well. So that's our final answer. The end. Plus